Good morning. It is Friday, May 8th, and today I can apply the components of sinusoidal functions in different ways by drawing a little picture. So we're going to be using trig graphs to answer questions, but we're not going to actually be graphing them or writing the equations. We're going to kind of be using the different components. And like the last lesson, the little picture is going to be a really big help to us. So that's what we're going to do. So the voltage used by most households can be modeled by a sine function. The maximum voltage is 120. All right, so it's a sine function. The maximum is 120. And there are 60 cycles every second. So that seems to have to do with the period. It's not the period, because the period is how long it takes to make one full cycle. If there are 60 cycles every second, if there's 60 cycles in 1 second, the question is, how many seconds does it take to make one cycle? So you can look at this as like a geometry thing where we're cross multiplying. If I do it that way, 60x equals 1. X equals 1/60th of a second. Or think of it using common sense. If it's 60 cycles in 1 second, then each cycle is 1/60th of a second. Either way, my period is 1/60. Which equation best represents the value of the voltage as it flows through the electric wires? Well, they're all the same. They all have the same amplitude. They all have sine. The only difference is the frequency. Remember, amp, sine, freq, x, shift. So the frequency is 2 pi over the period. So it's 2 pi over 1/60. To divide by a fraction, I keep change flip. I multiply by the reciprocal. And I get 120 pi. So my frequency is 120 pi. Choice 4 has got to be my answer. So again, if it's 60 cycles every second, that means the period, how long it takes to make one cycle, is 1/60. And from there, to use amp, sine, freq, x, shift, I find the frequency by doing 2 pi over the period, and that's all I need. Number 2 is pretty much the same thing, so I'm going to let you do that one on your own. And we're going to skip to number 3. The graph below represents the height above the ground, h in inches of a point on a triathlete's bike wheel during a training ride in terms of time t in seconds. Identify the period of the graph and describe what the period represents in this context. So this is should be a very simple question, at least the first part of it, to identify the period. Period is the wavelength. It's how long it takes to complete one full cycle. It's starting here. Where does the full cycle end? Here. What's the period? 2/3. That should be a very simple question. Again, period, I really hope at this point everyone understands what period is. It's how long it takes to complete one full cycle. One full cycle ends at 2/3. Now, what does it mean in the context of the problem? I know you guys always, I don't want to say you guys, but students always struggle with in the context of the problem questions, which the Regents loves to ask. Well, 2/3 is the time, t. So it takes 2/3 of a second for the wheel to make one full rotation. That's it. Again, period, it's really important that you understand what period is. It's just the wavelength. It's how long it takes to make one full cycle. The first full cycle ends at 2/3. And period is how long it takes to make one full cycle. In the context of this problem, one full cycle is one full rotation of the bike tire. All right. The height above the ground for a person riding a Ferris wheel after t seconds is modeled by h of t, blah, blah, blah. How many seconds does it take to go from the bottom of the wheel to the top of the wheel? Well, that's kind of like period, so let's start by finding the period. Period from a graph is where it makes one full cycle, and period algebraically is 2 pi over the frequency. Amp sine freq x shift. My frequency is pi over 45. So it's 2 pi over 45. That's 2 pi times 45 over pi. Again, when you divide by a fraction, keep, change, flip. My period is 90. Now, it's talking about how long it takes to get from the bottom of the wheel to the top of the wheel. And it's a sine, it's a positive sine. My period is 90. So it looks something like this. From the bottom of the wheel to the top of the wheel, well, it doesn't matter if I'm going from the top to the bottom or the bottom to the top, that's half of a wave. So if it's 90 seconds for the full wave, then it's half of that for half of the wave, and choice 2 is your answer. I would not call these easy questions. They're questions, they're short, but they're questions based on your understanding of the trig graphs, but there's applications to them, and applications lessons are always a little tricky because you have to wrap your head around what's going on and really understand all the components. Again, from the bottom of the wheel to the top of the wheel is half of a wave, so it's half of the period. Period is 2 pi over the frequency, and we know frequency is always what's between the sine or cosine and the variable. A sine function is increasing through the origin, can be used to model light waves. Violet light has a wavelength of 400. Wavelength is another word for period, so the period is 400. So let's draw my little picture. I know that the period is 400. It's a positive sine wave. Well, it's a sine wave increasing through the origin, which means it's going up first. Now, it wants to know over which interval the height of the wave is decreasing. So I need my x value. So I need my dashes. 1, 2, there's always a total of 5 points. This is 0. Now, we talked in earlier lessons, if I want to find out how much each dash is worth, I do the period divided by 4. The period divided by 4 will always tell you how much each dash is worth. So that makes this 100, 200, 300, and then of course I have 400. So it's asking over which interval is the height of the wave decreasing. Well, it's decreasing from here to here. That's 100 to 300. Choice 2 is your answer. So again, we said generally all we need to do when we're graphing is put the period at the end of the last dash. But in a question like this, if you need to know how much each dash is worth, it's always the period divided by 4 because there are 4 dashes. Same type of thing for number 6, so I'm going to skip that, let you try that one on your own. Tangent. So we didn't really talk much about tangent because they don't really ask much about tangent. But whenever you're dealing with tangent, I want you to just use the calculator. So we haven't really done graphing in the calculator for these types of functions because it gets messy and annoying for most of them. But for tan, let's just go into the calculator. So I'm going to go to y equals, I'm going to go to 2 tan x. Now, whenever you're doing a trig graph, I want you to go to zoom trig, which is option 7. So what you're doing when you're doing zoom trig is each dash is worth 90 or pi over 2. So it's 0, pi over 2, pi, 3 pi over 2, 2 pi. Or in other words, 0, 90, 180, 270, 360. So from 0 to pi over 2, we're talking about from here to the first dash. So let me snip this thing so we can actually see what's going on here. Um, so make this a little bigger. Too big. That'll be okay. No, from 0 to pi over 2. So again, this is 0. This is pi over 2. When you do zoom trig, it's going by pi over 2 or 90. So what's the graph doing? Well, is it increasing or decreasing? That is increasing. Is it increasing from 0 to 2, or is it increasing without limit? Well, it's increasing, and it's going way past 2. This is 2 right here. It's going on forever. We actually have asymptotes here in this picture. When you have your tan graph, your answer is choice 3. To make it simple, I'm trying not to open a whole can of worms with this unit here. If they talk about tan, just type it into the calculator. They're not going to ask you much about tan, if anything. Most likely they're not going to ask about tan. But if they do ask about tan, just type it into the calculator and use zoom 7, which is zoom trig. Same type of thing for secant and cosecant. So let's just do this one as well. Now, how do I type in cosecant into the calculator? Well, there is no cosecant button, but remember, cosecant is the reciprocal of sine. So I can type in 1 over sine x. So if I go to y equals alpha y equals enter 1 over sine x, again, that's how I would type in cosecant. There's no cosecant button. I have to put in 1 over sine. Again, I'm going to do zoom 7. I'm going to snip this thing so I can write on it. And I think I just froze this thing. Oh, I'm good, but I'm risking it. Let's see how long I can last. So from 3 pi over 2 to 2 pi. So again, this is pi over 2. It always goes by half pi. So that's pi. That's 3 pi over 2. And this is 2 pi. So it's talking about from here to here. Is it increasing or decreasing? Well, it's decreasing. Is it decreasing without limit, or is it decreasing to 1? It's going way past 1. It's going down and down and down and down forever. Choice 2 is your answer. So for tangent or the reciprocal functions, I would just type it into your calculator and do zoom trig, and understand that each dash is pi over 2, or 90 in degrees. And you can answer your questions based on that. All right, 9 is the same type of thing. That one you'll try on your own. I think this is one of the easiest questions in this this packet, this lesson here. And again, it's just kind of a random smattering of questions that are all based on trig graphs, where I'm not actually doing the trig graphs or writing the equation. Which statement is incorrect? Well, again, I want to draw a little picture. The key to all this stuff is drawing a little picture. If you draw a little picture, you'll be in good shape. The midline is 7. Let's go through the whole thing here. Amp, sine, freak x, shift. My amp is 3. It's a negative cosine. My freak is pi over 3. My shift is 7. We didn't talk much about this. This is a horizontal shift. We know from transformations this is going right 4. Doesn't really affect anything important here. So my shift is 7. My amp is 3. So I'm going up 3 and down 3. It's a negative cosine. period is 2 pi over the frequency. Let's just find some space to do that. So it's 2 pi times 3 over pi, which is 6. So the period is 6, yes. The amplitude is 3, yes. The range is 4 to 10. Well, its min is 4, its max is 10, yes. The midline is y equals -4. No, the midline is y equals 7. So this one's wrong, and that's your answer. Again, the key, just draw a little picture. Use your knowledge of trig graphs, of sinusoidal functions, and from here, this particular moment is pretty simple once you did that. Which function has a period of 8 and reaches a maximum height of 1 if at least one full period is graphed? So, this is kind of a good one to kind of do by eliminating stuff. It has a period of 8. So if it has a period of 8, being how I'm writing the equations, I need the frequency. So frequency is 2 pi over the period. So frequency is 2 pi over 8, which is pi over 4. So it can't be 3 or 4 because 3 or 4 have a frequency of 8. So basically the only difference here is the midline. Choice 1 is a midline of -3. Choice 2 has a midline of 5. So let's kind of do a little sketch for each. So this will be the -3. This will be the 5. The amp is 4. This is going up 4 and down 4. Up 4 and down 4. It says a maximum height of 1. Which of them has a maximum height of 1? The one with the midline at -3. Choice 1's your answer. So again, we're just using our knowledge of trig graphs. And again, these little pictures are very helpful. I also, based on how I had equations here, I knew that if I had the frequency, then I can, eliminate choices. And again, to find the frequency, it's 2 pi over the period. A lot of words in this question, which scares a lot of students, but, no big deal. Let's just read, it's not any worse than your English regions as far as reading. Just read through it. And it's actually not that bad of a question, as long as you understand all the components of trig graphs. Based on climate data that has been collected in Bar Harbor, Maine. Really awesome up there, by the way, in Bar Harbor, Maine. It's right outside Acadia National Park. If you ever can make it up there, it's pretty awesome. The average monthly temperature in degrees Fahrenheit can be modeled by the equation, blah, 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 blah. So I'm going to start with Bar Harbor. And I'm going to draw a little picture. Again, the key to all this stuff is to draw a little picture. So for b of x, my midline is 55.3. My amplitude is 23.914. So I'm going to my calculator right now and I'm adding and subtracting. When I add, I get 79.214. And then when I subtract the amplitude, I get 31.386. It's a positive sign. There's a little bit of a phase shift going on here, but again, it's a horizontal shift, but it's probably not going to matter much. And the period is always important. So the period is 2 pi over the frequency, which is 2 pi over 0.508. I guess I'll just do that as a decimal. So 2 pi divided by 0.508 is 12. I'll just call it 12.4. Now we've got another one for Phoenix, which is going to be p of x. So for Phoenix, the midline is 86.729. My amp is 20.238, so I'm going to add and subtract 20.238. And I get 66.491 and 106.967. Notice I haven't even looked at the answers yet. I'm just finding all the important information that I need for this thing. Period is 2 pi over the frequency, which is 0.525. In general, when I make my little picture, I want my frequency, and then I want my max, mid, and min. So that's what I'm doing without even looking at the question. At this point, I'm just getting all the information that I'm probably going to need. It's about 12. Which statement cannot be concluded based on the information? So the average monthly temperature variation is more in Bar Harbor than in Phoenix. Average monthly temperature variation. How much the temperature is varying. How much the temperature is going up or down. This is asking about amplitude. This is saying the amplitude is more in Bar Harbor than in Phoenix. Well, in Bar Harbor, it's 23. In Phoenix, it's 20. So yes, the variation, the amplitude in Bar Harbor is more than in Phoenix. The midline average monthly temperatures, so it's telling you the midline. If it didn't say midline, it could just say the average monthly temperatures. If it's talking about average, it's talking about midline. So the midline for Bar Harbor is lower than the midline for Phoenix. Well, 55.3 is definitely lower than 86.729, so yes, that one is true. The maximum average monthly temperature for Bar Harbor is 79. So it's telling you exactly what it's looking at. The maximum. Is the maximum for Bar Harbor 79? Yes, to the nearest degree. The minimum average monthly temperature for Phoenix is 20 degrees. Nope. The minimum for Phoenix is 66.491. Choice 4 isn't true. To be honest, if you had a little bit of common sense of your country and what the temperature is like in Maine as opposed to Phoenix, this is you can kind of common sense your way through this thing. But, mathematically, we just did it. It's all about your little pictures. This question was a little annoying. Choice 1 was tough because average monthly temperature variation. A lot of students might not realize that that's talking about amplitude, but that's what amplitude is. It's how much it's changing from the midline. It's how much it's varying from the average. Number 13, tides are a periodic rise and fall of ocean water. On a typical day at a seaport, to predict the time of the next high tide, the most important value to have would be, it wants the time. If I'm drawing my little picture, this is the max height. This is the min height. This is the average height. And the period is how long? One full cycle. So if it's saying time is going to have to deal with the period. Time is your x-axis. The value that deals with the x-axis, the time is your period. So which of these is going to give you period? The time when the tide height is 20 feet. Well, that's time, but knowing when it's 20 feet, I need two pieces of information. I need to know, from start to end or some type of measure. If I'm talking about, it doesn't say what type of graph it is. Let's just say it's a, I don't know, negative cosine. 20 feet, it's irrelevant. I don't know where 20 feet falls in this thing, so I don't know if it just hits once, if it hits twice. That's not enough information. The time between consecutive low tides. That's the period. That's by definition the period. The average depth of water, well, that's the midline, which does not help me with the period. The difference between the water height at low tide and high tide, well, that has to do with the amplitude. Again, nothing to do with time, nothing to do with period. Choice 1 is your answer. All right, if it wants to know the time of the next high tide, I need to know the period. The period is, by definition, the time between consecutive low tides or the time between consecutive high tides. In this case, choice 1 was the only one that was there. That's your answer. Considering the function h of x equals 2 sine 3x plus 1, let's draw my little picture. Amp sine freak x shifts, amp sine freak x shift, amp sine freak x shifts. Little picture. Amp is 2, positive sine, freak is 3, shift is 1, 1, plus 2, minus 2, positive sine, period is 2 pi over the frequency, 2 pi over 3. Determine which function has the smaller minimum value from negative 2 to 2. Well, this thing goes on forever. The minimum value for this one is negative 1. What's the minimum value for this one? Well, negative 8 is the smallest value I see. Which one has a smaller minimum? Q of x. Because negative 8 is a smaller minimum than negative 1. This, I think, was a pretty easy question, again, as long as you draw your little picture and understand how trig graphs work. I'm going to let you do 15 on your own. 16, the volume of air in a person's lungs as the person breathes in and out can be modeled by a sine graph. A scientist is studying the difference in this volume for people at rest compared to people told to take a deep breath. When examining the graphs, should the scientist focus on the amplitude, the period, or the midline? Explain your choice. I don't love this question. I was reading this a long time ago. They haven't asked anything since. I think they didn't like this question, which is why they didn't really ask anything like that since. But if you're talking about how much you're breathing in and out, you're talking about how much your lungs are expanding. Well, the period is how long it would take. If you're talking about the actual volume in your lungs, how much they're filling up, how much they're going up and then back, that's amplitude. Amplitude is how much your lungs are filling up. Period is how long it takes to take the breath. And midline would be, I don't even know what that would be in the context of this question. The average volume of your lungs while breathing, I guess, would be what the midline would represent here. But the amplitude is how much your lungs are filling up. So this lesson, I don't consider it an easy lesson. It's at the end of this unit because now that we've ideally mastered trig graphs, we're just answering a random smattering of questions based on trig graphs. So you have to use your knowledge of trig graphs, wrap your head around each question, and answer the question. The one thing that remains pretty standard throughout all of these is to draw your little picture, because once you draw your little picture with your max, your midline, your min, and your period, you're in a lot better shape in order to answer the question. So your classwork/homework is to finish the worksheet, We're going to have a quiz due. Well, this lesson is supposed to be for Friday and Monday, so we'll say the quiz is going to be due Tuesday. And on Tuesday, we're going to have a review, and then we're going to have our test next week. Any questions, reach out to me and remind. And again, if you have not been doing your work and this is the first lesson you're looking at, then you have no idea what's going on. You have to go back and understand how to do trig graphs. The whole unit, this is the end of the unit. You have to know everything we've done before this lesson in order to do this lesson. Reach out to me, remind with any questions, and I hope everyone has a great day and has a great weekend.